Okay, so now we'll turn to hypothesis testing for proportions. The steps are basically the same. We're going to set up our hypotheses, enter the data, and then if the p-value is less than alpha, we'll reject the null. So it's really important to set up our hypotheses from the beginning so that we can make an easier interpretation of the conclusion. So again, the equal sign will always be in the null hypothesis. We'll always use population symbols, and we'll always have the same number in the null and alternate hypothesis. So let's say I'm hypothesizing that crime rate went down. I would have a less than sign in my alternate hypothesis. If I'm hypothesizing that graduation rates went up, I would have a greater than sign in my alternate hypothesis and always have the equal sign in the null. In fact, as a quick rule, you could always just put the equal sign. You don't have to put the less than or equal to like you see there. Okay, so let's look at a problem. Dell's coming out with more customized laptops, new designs and colors. Before the change, 45% of people in the market for a laptop purchased a Dell instead of other brands. And then we tested things out. We asked 50 customers at a local Best Buy how likely it would be that they would purchase a Dell after showing them pictures of some of the new design options. 30 out of those 50 said they would purchase a Dell. Does this data show that the customized laptops would significantly increase the proportion of customers opting for a Dell? And we've got 10% level of significance there. So notice the 45% is what I'm trying to disprove. I'm trying to say it's more than 45% now, because that's what it was before the change, 45%. So if the colors and designs work, then I should be seeing a percent above 45%. So my alternate hypothesis is greater than 45%, which means my null less than or equal to 45%. Now my new information is 30 out of 50. Okay, so what are the hypotheses? Basically that, the alternate hypothesis is greater than 45%, the null is less than or equal to 45%, or you could just use the equal sign. This is going to be a right tail test or a greater than problem because I'm claiming that it went up from 45. I always look at the sign in the alternate hypothesis. And what value goes in the hypotheses? It's that 45%. That's the hypothesized proportion that we're trying to say went up. Okay, so the next step is to enter the data based on those 50 customers. Okay, so you make the conclusion using the p-value. Either I can say, yes, the new designs work because I find evidence that it's greater than 45%, or I say, no, the new designs don't work because I didn't find enough evidence for the greater than 45%. So here's what we do. Again, go to Megastat and hypothesis test, but this time we're going to do proportion versus hypothesized value. Okay, and in this case you can either put the x over n, so the 30 out of 50, or if you went ahead and calculated the proportion, divided 30 by 50, you could just enter the 0.6 in there, and because of the decimal place it would know it was a p, so it would change that x to a p. Okay, but in this case it has 30 out of 50, you might as well just let it do the calculation for us. The hypothesized is not 0.6 because that's what's observed. What we're trying to disprove is the 0.45, and we're trying to say it went up with the new designs. And if you recall, the problem said 10% level of significance, so I would change the confidence level to 90%. Okay, so my p-value is 0.0165. 0.0165 is less than 0.1, so we can reject the null. If we're rejecting the null, that means we're supporting the alternate. We're supporting the claim. We have enough evidence for the claim. So there is evidence that the proportion has gone up with the new designs. So the decision, keep up with the new designs, it seems to work. Okay, let's look at another problem. A TV commercial for a toothpaste claims that more than 4 out of 5 dentists recommend the product. So notice that wording. Claims that more than 4 out of 5 recommend the product. So the claim, or alternate hypothesis, is greater than 4 out of 5. A consumer protection group polls 400 dentists and finds that 329 recommend the product. Can we infer that the claim is true if the level of significance, or alpha, is 10%? Okay, so notice how I've set up the hypotheses here. The claim is that it's going to be greater than 4 out of 5, and I can always have the equal sign in the null. So basically, either I find evidence for the alternate or I don't. Either I find evidence for greater than 4 out of 5 or I don't and just go with the null. Okay, so again, hypothesis tests, proportion versus hypothesized value. That hypothesized value is going to be that 4 out of 5. Okay, I observed 329 out of 400, so it'll calculate my sample proportion there. What I'm trying to disprove is the 4 out of 5, and I can just enter it like that. I don't have to, calculate it and put it in as a decimal. It'll calculate the 4 out of 5. It's a greater than problem because I'm trying to say that it's gone up from 4 out of 5, or it's greater than 4 out of 5 with the 90% confidence level. Okay, so my p-value is 0.1303, and you can see they've done the other data there. The observed was about 82%, whereas the hypothesized was about 80%. So what I'm trying to prove is whether that 82 is statistically significantly greater than 0.8 given the sample size. Okay. So 0.13 is not less than 0.1, so I can't reject the null. That means I don't have enough evidence to suggest that it's more than 4 out of 5 dentists. Remember, I'm trying to prove or disprove, or I'm trying to find evidence for the alternate or not. I'm not trying to prove or disprove the null. It's just that if I don't have enough evidence, then I have to go with the null. If I don't have enough evidence for guilt, then I have to go with innocence. Okay, let's look at another problem. A tire manufacturer has developed a new ultra-high performance tire they believe has better wear than the tire they are currently selling. The tire currently on the market has an average life of 20,000 miles. The engineers tell you that the variability on the wear of the tire has not changed, but the company would like to claim that their newly developed tire has increased life. Okay, so notice I'm going back to a mean problem. Which of the following set of hypotheses would be the correct set for the company to use in order to be able to claim that the new tire has a longer life than the current tire? Notice this says average life of 20,000 miles. And the claim is that it's longer life than the current tire. So I'd have greater than 20,000 in my alternate hypothesis. So the only option there would be A. And it checks out because the equal sign is in the null. Okay. According to the Bureau of Transportation Statistics, Untied's carrier share at Denver DIA was 43.69% for 2006. Has the carrier share changed in 2007? State the null and alternate hypotheses. Okay, so notice just wanting to know if it's different from the 43.69%. So this, again, would be a proportion problem. Equal sign in the null. Same number in both the null and the alternate. Not saying it's gone up or gone down. Just want the not equal to in the claim. Okay, let's move further with that same problem. Suppose we get a sample of 500 passengers, and that shows that 241 of them flew on untied. Recall that the proportion before is 0.4369. So basically, I'm wanting to prove that 241 out of 500 is less than, or sorry, not equal to 0.4369. Okay? So basically, I have 241 out of 500, my sample proportion. I'm trying to disprove the hypothesized proportion of 0.4369. I have a level of significance of 0.05, and it's a not equal to problem. Okay, so there's the 241 out of 500, my sample proportion, the hypothesized that I'm trying to disprove, and then a not equal to problem. My level of significance is now 5%, so confidence is 95%. Hit OK, and I get a p-value of 0.0420. Since that's less than 0.05, I can reject the null, and I do have evidence that the proportion has changed. The proportion is different from that original 0.4369. Okay, we just have evidence that it's changed. We don't, we haven't really tried to prove that it's less than or greater than. As a decision maker, it might be more helpful to know if it's gone down or up. Okay, so my observed was 0.482. I see obviously that's higher than 0.4369, but I need to test whether that's statistically significant or not. And the p-value is 0.042. So let's make it a greater than problem now. Since we did see that the sample proportion was greater than the hypothesized 0.4369, let's test if it's statistically significantly greater. Okay, 0.02 is less than 0.05, so we can reject the null, and we have evidence that the proportion has gone up. Things are going well for untied. We may want to analyze why that went up and keep it up. Okay. To be competitive in the US market, we would like to show that we lose less luggage than the other airlines. So notice that less than. It's going to be a less than problem. A recent study showed that the lost luggage percentage is 1%. So that's basically the status quo benchmark background material or percentage that we're trying to disprove. We think it's less than 1%. That's what we're trying to prove. Okay, we want to use sample information to claim that we lose less luggage than the industry as a whole. And you find of 1,400 bags checked, 10 were lost. So what should the airline conclude based on your data? Okay, so notice the sample proportion is 10 out of 1,400. I'm trying to claim that it's less than 1%. So I have a less than sign in my alternate hypothesis. I'm claiming less than 1%. Make sure to put 0.01 as your proportion. And here's how we would do that in Megastat. Again, we're doing hypothesis tests, proportions versus hypothesized value. 10 out of 1,400 is what I found. The hypothesized is the 1%. So again, put the 0.01. And I'm saying that it's gone down from the 1%, or that it's less than the 1%. With 95% confidence, or level of significance of 5%. Okay, my p-value is 0.1413. 0.1413 is not less than the common levels of significance. So sometimes you don't have to be given the level of significance, because the p-value is going to be either so high or so low that it's just not, you're going to get the same conclusion no matter what the level of significance is. And you'll notice it didn't highlight the p-value. If you don't give it the level of significance, it doesn't know whether it's significant or not. In this case, it wouldn't be highlighted anyway because it's too high. But basically, since 0.1413 is not less than the common levels of significance, 0.1, 0.05, and 0.01 representing, the common 90, 95, and 99% levels of significant or confidence levels, we cannot reject the null. So basically, we haven't shown that it's less than 1%. There's no evidence that it is less than the industry average of 1%. Okay, remember my claim was less than 1%. That's what we were trying to prove. We didn't have enough evidence to prove that, so we're going with the null that it's equal to or greater than 1%. Okay, notice my sample produced a 0.7% result. That is not statistically significantly lower than 1%. Okay, so more decisions related to this chapter material. Accommodate for the fact that more people are buying hybrid cars. Make some changes since sales have gone down significantly. Modify the menu since more people are leaning towards healthier options. And people are spending less on luxury travel, so make more staycation options. So these are the kinds of decisions that would come out of hypothesis testing, whether it be for testing the mean or proportion.